welcome to Chapter 1, Section 1 of the Algebra 1 program. I would like to welcome anyone who's new to these programs. I am Michelle, and I will be your captain on these videos. And I'm going to do my best to keep the videos short and sweet, but also thorough enough that you have several example types. You guys should all have the layout of the lesson plans, and you need to make sure that you're doing the review questions before you watch the new video. Then as you watch these videos, I expect you guys to be taking notes and writing down everything that you see. The nice thing is with the video is you can pause it and make sure you're all caught up. And then you're to read through the section of the new materials before beginning the assignment. So all of that together should really help your understanding of the concepts. Algebra 1 is an enormous change in our mathematical thinking. So up to this point, all of the math that we have done has been what we call concrete mathematics, which means we've been able to model it some way. We can see what we're doing. We can model it with blocks or things like that. And then in algebra, we represent unknowns by using letters. So this is what we call a variable. So a variable is simply a letter that we see where we are trying to figure out what we don't know. So it's a huge change in our mathematical thinking. I know a lot of times students kind of freak out because they think, what are letters doing in math? Math is just supposed to be about numbers. But this is a growing in our mathematical understanding, and there's so many fun things that we can do with variables. So that is what this course is designed for. So the first semester is going to be a hard crash course in functions and being able to work and solve a whole variety of functions. And then second semester, we're going to work hard at all of our graphing functions and being able to analyze those sorts of things. So I'm hoping that chapter 1 here is a lot of review. I'm hoping all of you have had pre-algebra before. So the chapter 1 should be a mostly pre-algebra review, but don't hesitate to go back and do what it takes to make sure that you are all caught up and you kind of know what we're doing here. And then hopefully things will go pretty smoothly for you. So hopefully my first couple of videos will be pretty short, just a nice review of how to do some basic concepts before we get going here. Okay, so in this first section, we're just talking about using and manipulating variables a bit. So just to remind you, mathematics has its own vocab, and it would be important for you guys to write this down in your notes for good reference. But when you see the words like add or sum, we need to translate that and know that mathematically we need to do addition. Similarly, when we see the words difference or subtract, we need to know that that represents subtraction. Product, of course, implies multiplication, and quotient implies division. So much of math is about understanding the vocabulary, so we're really going to hone in on that. If you don't understand the vocab, then you're not going to understand what you need to do to solve. All right, so let's get going. Early on, pause the video if you guys don't have that written down yet, and jump back in. What if we wanted to write an expression and they gave us 6 more than x? How would we write that? Well, again, we're going to highlight the word here that we need to translate, more, and more for us, according to our box, represents addition. So it would be 6 plus, and then our unknown here, x. So this is the expression they want us to write, 6 plus x. Okay, what if we had the product of 7 and 12? What I need you to do is identify the word in there that needs to have the translation. In this case, it's product, and product represents for us multiplication. So we want the multiplication of 7 and 12. So that is going to look something like this. Now, perhaps in your pre-algebra program, you were still allowed to write multiplication with an x. No longer are we allowed to do that. X now for us is going to represent something else. so it cannot represent multiplication. So for our purposes moving forward here for the rest of your mathematical life, if you ever have to write the product of two values, we're going to use that dot. Okay, hopefully that's not terribly new to you, but I hope the change isn't too frustrating. Okay, so you're going to have several questions like this in your homework where you just have to write the expression. Again, I'm hoping that that's, not too difficult for you. All right, what if we had something like 18 less than a number? Oh yeah, and I do want to apologize right off the bat. I legitimately failed handwriting when I was in school. I have done my best with this computer program to practice. I'm hoping that my commentary will help you read my writing as well as possible. But don't hesitate to send me a text if you're like, hey, Michelle, I don't have any idea what you just wrote in that video. I will do my best. Writing on a computer screen is not particularly easy either. So anyway, best of luck to you. Okay, so what if we had something like less than? We haven't really talked about that. That wasn't really in our box, but hopefully you could interpret that to mean subtraction. And we don't know what a number is. Like before, it had given us a letter, and now we have to assign a letter. And you can use any letter that you want, but just so you guys know, I'm very partial to simply X. So I like X. I'm going to use him a lot, but you're welcome to use any. And we need to be careful. A lot of students would then just read this and say, oh, so then it's 18 minus X. No problem. But that's actually not what it says. It says 18 less than a number. So it means there's a number, there exists a number, and then we're going to take 18 away from that. So you need to be really careful with subtraction specifically. Order matters. So don't just be quick then to like throw down your number in your letter. Make sure that you're writing it. It's 18 less than a number. So be careful there. All right, let's do another one like that. What if we had something like 3 more than twice a number? Okay, so a couple of words we need to highlight here. 3 more. So we see more and we know that more represents addition. And then we haven't seen this yet. What if we have like twice a number? Well, it's going to be 2 times that number. And again, we have to assign a letter to this unknown value here, and I like to use X. So we need 3 more than a number, and then twice that number would actually be 2X. So 3 more than twice a number would be 3 plus 2X. Or if we write it exactly the way that it sounds, it would actually be 2X plus 3. But if you notice, addition is what we call commutative. And so the order doesn't matter for addition. So you can be more free with the way that you place your terms because order doesn't matter. But when we talk subtraction, it does. So be very careful when you're doing subtraction. All right, what if we had something like the total cost of the number of items times 1.15. Okay, so now we have a lot of things going on in this one, and this is going to come in at the end of your assignment. So first we have something like the total cost, right? So we're going to be putting something together, and we're going to get a number, and it's going to represent our total cost. So for that guy, I think I'm going to use like a big C to represent total cost. And then of a number, again, I need to assign a number. I'm going to use the letter X. The cost of a number times Times is another word. We might want to add that to our box. Representing multiplication, right? Remember multiplication, we're going to represent with a dot, or you could maybe write just like multiply, something like that. Times 1.15. So I know C is equal to a number times 1.15. All right, and just a side note here, again, I don't know what you were taught in your pre-algebra program if you did one other than the one that I produced last year, but whenever you have a variable and a number, we don't need any kind of signage to represent multiplication. We simply just put the values together, and that denotes multiplication. We do need some sort of mark if we have like two numbers, right? Because otherwise we're not sure what to do with those numbers. But when it comes to variables, if you have a number and a variable, then you're just going to put them together and that automatically denotes multiplication. So in this type of problem, we had two unknowns and we had to interpret the operation here. So I'm going to do one more example like that, and then hopefully you guys will feel good and you'll be ready to get going. I also don't write out the problems ahead of time because I want to give you the chance to maybe write as I'm writing, and that will help you save time a little bit instead of having to watch the videos and keep pausing and all of that. Okay, so the number of slices of pie you have left out of a 10 slice pie. All right, so we need to know how many slices we have left. So I would say the number of slices remaining would be S. Let's call that S. That you have left. What operation could that denote? So you're thinking it's addition, subtraction, multiplication, or division. Well, if you take some away, what you have left usually indicates subtraction. And then out of a 10 slice pie, so that's how many we were starting with, right? So the number of slices you have left when you have a 10 slice pie and you ate some. So that is going to tell you how much is left. All right, you guys, at this point, I want you to finish up your notes. I want you to read through the examples in the book and begin your assignment.